Hi everyone, welcome to the factoring test review video. I'm sitting here with a couple of my friends.
Madison.
And Big Daddy.
AKA Sergio. And we're going to go ahead and work through some of these problems together. So on problem 1, they ask us what the greatest common factor for the following expression, 4x to the 5th minus 24x to the 3rd minus 9x squared is. Well, the greatest common factor is something that divides evenly into all three of those things. So I look at my numbers first, and I think, what is the largest number that divides into 4, 24, and 9? And there is nothing that divides except for 1. 1 is the only number that goes into all three of those numbers evenly. And then I now look at my variables, and I realize that they all have an x with them. And not only that, they all at least have an x squared. So my GCF is 1x squared. Now, you do not have to put that 1 in front of the x squared. You really can just write x squared and you're good to go. Okay, so moving on to number 2. If a rectangular fence has a length of 4x plus 2 and the width is 3x minus 1, what's the area of the pasture it encloses? Well, we know area is length times width of a rectangle, so we can go ahead and plug in our length, which is 4x plus 2, and then our width, which is 3x minus 1, into our formula. We have two binomials being multiplied together, and when we have that, we have a couple options. We can either box method or FOIL. I'm going to go ahead and box method this, so we put on the outside, we put 4x plus 2 and 3x minus 1 outside of our box. And they're wanting the area, so we multiply. So we multiply 3x and 4x, and we get 12x squared. We multiply 3x and 2, and we get 6x. We multiply 4x and negative 1, and we get negative 4x. And then we multiply 2 and negative 1, and we get negative 2. So I'm going to go ahead and write down everything inside my box. So it's 12x squared plus 6x minus 4x minus 2. Then I get to combine like terms, and I get 12x squared plus 2x minus 2. And the 2x came because 6x minus 4x is 2x. So my answer is 12x squared plus 2x minus 2. And that's the area. All right, number 3 says, which of these is a factor of 6x squared plus x minus 2? And whenever we're factoring, the first thing we have to do is find the GCF. If there's a GCF, we want to pull that out as one of our factors. In this case, there is no GCF. So we don't need to do that. And we also realize that there is a number in front of our x squared. So because there is a number in front of the x squared, the option we have to do is reverse box method. So by reversing the box method, we draw our box, and we put 6x squared in the top upper left-hand corner, and then negative 2 in the lower bottom-hand corner. Then we multiply. So we're going to multiply 6 times negative 2, and we get negative 12. And now Sergio is going to tell us what the factors of negative 12 are.
The factors of 12 are 1 and 12, 2 and 6, and 3 and 4.
All right, and we know now that they have to add up to a positive 1. And because they add up to a positive number and multiply to a negative number, we know that one of these has to be negative. And because it's adding up to a positive 1, the smaller numbers get the negative. And so our answer, the ones that add up to positive 1 are negative 3 and 4. So I'm going to fill those in my box. It doesn't matter which order we put them in. They'll all work out to give us the same answer. And now I pull out my GCF. So I first look at the negative 3x and the negative 2. And the GCF there is 1. And we pull out a negative because that box closest to the one where we pulled out the 1 is negative. Now I look at the GCF between 6x squared and 4x, and the GCF there is 2x. And the GCF between 6x squared and 3x, negative 3x, is 2x. And then the GCF between 4x and negative 2 is 2x. All right, I made a mistake. Instead of it being 2x, we need to pull out a 3x. That was Madison who caught that. And it shouldn't be 2x, it should be 2. Sorry about that. So now we know our factors of this area are 2x minus 1 and 3x plus 2. So they give us options, and we have to figure out which one of these, A, B, C, or D, is a factor of 2. And the answer is B. Okay. Number 4 says the area of a solar panel is on a calculator is 2x squared plus 4x centimeters squared, and they want us to factor the polynomial to find the dimensions. Well, let's remember that our options for factoring, the first thing we always do is look for the GCF. And in this case, the GCF, they both, 2 and 4 are both divisible by 2. So we pull out a 2, and then they also both have an x. So I'm going to pull out an x. And then what's left over on the inside is x plus 2. So that is the factors that is the area factored. So our factors of the solar panel, or the dimensions, are 2x by x plus 2 centimeters. Okay, and let's finish our list. Had the GCF not worked, the other 3 options that we have are setting up shop, reverse box method, and DOPS, or difference of perfect squares. So those are the things that we're looking to do as we move on throughout the review. Okay, on number 5, it says a rectangular calculator box has an area of x squared minus 7x plus 10 square units. And which of the following would be a possible expression for the length of the box? Well, whenever we're given an area, to find the dimensions, we have to factor it. So I'm going to be given x squared minus 7x plus 10. And once again, we look to see if there's a GCF first. And in this case, there is no GCF. So then we go ahead and look to our other options. And we see, can we set up shop? Well, we can set up shop because there is not a number in front of x squared. And the way we set up shop is we put 2 sets of parentheses, and we put an x and an x in the front. And then we have to find 2 numbers that multiply to 10 and add to negative 7. And the 2 numbers that multiply to a positive 10 but add to a negative 7 are negative 2 and negative 5. Okay, so those are dimensions of this rectangle. So it's an x minus 2 by x minus 5 rectangle. And when we look at our answer choices, the only option that I see that works is x minus 5. So the answer is A. Okay, let's move on to 6. It's asking us to factor the binomial x squared minus 36. And which of these could be a factor? Well, we have to look first at GCF, and we don't see anything that these 2 terms have in common. The next thing we do is see if we have a difference of perfect squares. Well, I realize I have 2 things being subtracted from one another, so that's a big hint. So we're on the right track for difference of perfect squares because of the subtraction sign. Now we have to see if x squared is a perfect square. Well, it is, because x squared is x times x. And 36 is 6 times 6. So we have 2 perfect squares being subtracted from one another. So now I know I'm going to use DOPS on this. And when we do that, we set up 2 sets of parentheses. We put our first base in the first spot of our parentheses. So our first base is x. And then in the back of our parentheses, we put 6. And so we have x in the front and 6 in the back, and one always gets a plus sign and one always gets a minus sign. And we ask which of these could be a factor. And the answer choice that I got were 1 and 3. Okay, so let's move on. Okay, I'm going to let Madison go ahead and teach y'all number 7. So here she is.
Okay. So 6x squared plus 14x and plus 4. We have to find or see if there's any great GCFs, and there is, and it's 2. Okay. And then for the variables, they don't have a variable. Okay. And then we bring what's left, and it's 3x squared plus 7x plus 2. And we divided it from what's there. So then we take what we have left, and then we can't do DOPS because there's not a difference, or we can't do setting up shop because there's a 3 in front of the x squared, so we have to do reverse box method. And so we bring the 3x squared on the top left, and then the 2 on the bottom right, and then we multiply it, so it would be 6. So then the multiples of 6 are 1 and 6 and 2 and 3. And so to find which one that adds up to 7x would be 1 and 6. So 1x and 6x. And then now we have to find our GCFs for on the rows and columns. So the row with 1x and 2 would be 1, the GCF, and then the 3x squared and 6x would be 3x. And it would be a positive 1 because the box near it is a positive. And then 3x squared and 1x would be, the GCF would be x. And then 2x and, or 6x and 2, the GCF would be 2 plus 2. So then we would bring our 2 over there, or bring it down, and then it'd be x plus 2 and 3x plus 1. And that's all, and that's the answer.
Okay, so the next, problem 8, we have to simplify this expression. Well, first of all, I see an exponent, so I need to deal with that. And x plus 4 squared is the same thing as writing x plus 4 times x plus 4. And then we bring down the minus 24. So now, in order to multiply x plus 4 and x plus 4, I'm going to create and do, I'm multiplying a binomial times a binomial. So I'm going to do a box method or FOIL. Either way works. I'm going to choose box method and multiply. So I put my x plus 4s on the outside, and then I go ahead and multiply, and I end up getting an x squared for the first box, 4x, and then 4x, and then I get a 16 on the bottom. So what I end up getting when I multiply x plus 4 times x plus 4 is x squared plus 4x plus 4x plus 16 minus, and you keep bringing down that minus 24. Now I just need to combine like terms. So there's only one x squared term, and then I need to combine my x's. So I have a 4x and a 4x, and when I add those together, that gives me 8x. And then 16 minus 24 is negative 8. And that is my final answer. It says, number 9 says the area of a stable is 5x squared plus 9x plus 4 square feet. And they want us to factor the polynomial completely to find the dimensions. Well, remember, we look for GCF first, and 5, 9, and 4 don't contain any GCFs in common. And 4 doesn't have an x, so we can't pull anything out. Then we think about difference of perfect squares, and I don't see a difference of perfect squares here because there's no subtraction signs. And then the last things that we look at are setting up shop, And I can't set up shop because there's a 5 in front. So the last option is reverse box method. And I put the 5x squared up in the top left-hand corner. I put a 4 in the lower right-hand corner. And then I put my little circle and I multiply. So 5 times 4 is 20. And then I have to find the factors of 20. And I'm going to want them to add up to positive 9. So I put 1 and 20, 2 and 10, 4 and 5. And 4 and 5 are the ones that add up to 9. So I'm going to put in my empty boxes 4x and 5x. Then I have to pull out the GCF. So the GCF between 4x and 4 is a positive 4. And it gets a positive because the box closest to it is positive. Then I need to find the GCF between 5x squared and 5x. And I get to pull out a 5x. The GCF between 5x squared and 4x is just 1x. And the GCF between 5x and 4 is positive 1. So I factor that out to be 5x plus 4 times x plus 1. And that is the factored form of the area, so that tells me my dimensions are 5x plus 4 by x plus 1. Okay, on number 10, they ask us to write the polynomial modeled and then factor. Well, we remember that the larger squares are x squared, so we have one positive x squared. And then we have our x bars. So we have 2 positive x's and 3 negative x's. So I write a plus 2x and a minus 3x. Because remember, shading means negative. And then I have 6 shaded little squares, so that's a minus 6. I combine like terms and I get x squared minus x minus 6. Okay, so now I need to factor. That's the polynomial that I need to factor. And I look for a GCF first. And there is no GCF here to pull out because 1, -1, and -6 do not have anything in common. So I look for difference of perfect squares, and that I do not have. So the next option is setting up shop, which I can do because there's no number in front of the x squared. So the way I set up shop is I put an x and an x in front. Then I pick 2 numbers that multiply to -6 but add to -1. And that's going to be -3 and positive 2. And that is my answer right there. I'm done. All right, number 11 asks us to model using algebra tiles x minus 1 times x plus 2. So I'm going to go ahead and draw my little algebra tile mat that I usually draw. That looks like that. And then I need to put my factors on the top and the side. So I have an x minus 1. So remember, positive x is just an unshaded bar. And then I put a -1 unit next to it. So in order to show something's negative, I shade it in. And then along the side, I put an x, a positive x bar, and then 2 positive units. And then I multiply. So an x times x gives me an x squared, which fits perfectly right in between those 2 things in the upper left-hand corner. And then I have an x bar times a -1 unit. So that means I'm going to draw an x bar and shade it in to give me a -x. And then I have a positive 1 unit times an x bar, and that gives me a positive x. And then I have my 1 unit times a -1 unit, and that I'm going to shade in as a -1. Then I have a 1 times an x, positive 1 times positive x bar. That gives me a positive x bar. And then a 1 times a -1 gives me a -1 unit. So that is all I need to do there, modeling algebra tiles. So, and if I wanted to write the algebraic expression instead of writing it in algebraic tiles, it would be x squared plus 2x minus x minus 2. And then when I simplify it, it would be x squared plus x minus 2 would be the final answer.
What was he finding?
Problem 12 asks us to completely factor the polynomial 3x squared plus 15x plus 18. So I have to pull out first, always look for a GCF. Well, the GCF in this case is going to be 3, because 3 is the largest number that goes into 3, 15, and 18. So I pull out a 3, and what I'm left with inside is x squared plus 5x plus 6. All I did was divide each term by 3 when I pulled it out. So now I see if I can go ahead and factor this even more. And I'm going to go ahead and say that it's not a difference of perfect squares, so I'm going to move on to setting up shop. And I can set up shop with what's inside the parentheses because there's not a number inside or in front of the x squared. So I'm going to go ahead and set up shop and put an x and an x in front, still bringing down that 3 with me. And I need two numbers that multiply to 6 but add to 5. And that's going to be positive 2 and positive 3. So that is my completely factored polynomial right there. There's nothing else I can do. Okay, and the last problem says that the length of a rectangle is x minus 7 and its width is x plus 4, and they want us to simplify. Or they ask us for the area and want us to simplify. Well, we know area is length times width for a rectangle. So area equals the length is x minus 7 times the width, which is x plus 4. And I have two binomials being multiplied by one another. So I'm going to use box method. You are welcome to use FOIL if you would like. And I put the x minus 7 on top and the x plus 4 on the side. Because remember, we're multiplying here, not factoring. Some of y'all are going to be tempted to start filling in the boxes when you don't need to. So when I multiply x times x, you get x squared. And when you multiply x times negative 7, you get negative 7x. 4 times x gives you 4x. And then 4 times negative 7 is negative 28. So my area is equal to x squared minus 7x plus 4x minus 28. And then I simplify. So the area is x squared minus 3x minus 28. Okay, so that is my final answer to this review. But remember, I want you to write down on your review right now the 4 factoring methods that we use. The first is GCF. You should always look to factor out the GCF. The second is DOPS. See if you have two perfect squares being subtracted from one another. Third, we're going to try and set up shop. And then last but not least, if you can't set up shop because there's a number in front of your x squared, you're going to do the reverse box method. Okay, I really hope this review video helps. Remember, I'll be here for tutoring in the morning at 6:45, and I will see y'all tomorrow. Good luck studying.